We are Olivier Levillain and Pierre Chifflier. We work for the ANSI, the Agence Nationale de la Sécurité des Systèmes d'Information. In English, it translates to French Network and Information Security Agency. I have been working there for 8 years, first in the laboratories, and this year I have changed and I work in the training center now. I am a PhD student since 2011. Okay, I think I have something to do this year, but I'm not sure. And okay, I also worked on the languages since 2007 in ANSI.
Hello, so I'm Pierre Chifflier. Well, I'm gonna do that fast because it's not really that interesting. So I work also for the ANSI, from systems to network to many things. I do some stuff in many different areas, starting from BIOS to languages, compilers, and many kind of stuff. So, well, we'll see.
Okay, so ANSI, just a word. Our work is to raise the security level in France, and we target governmental entities, companies, and the general public. And in France, we have a separation between the Intel agency and the security agency, the ANSI. So we did not do Babar. It's not us. Sorry.
In short, we are like the 3 or 4 letter agencies, but we are the good guys. Okay.
Okay, so why are we here to speak about languages? Back in 2005, the ANSI, it was not the same name at the time, was asked a question about whether Java was a good language to write security products. The question was a good one, and in fact we tried to broaden it across years, and we had some questions. Which language is better than the other, and which criteria would we like to look at? Should we forbid, discourage, recommend, or require some constructions of a particular language? And if we could start from a clean slate, what would we like to get? So at the time, and still today, we think few people considered the question in such a broad way. So this presentation is about examples in languages and the impact of the language, some constructions on the security. We have a broad spectrum of examples in different languages. If you need more information on the subject, we had 2 studies from since 2005 called JavaSec and LaFoSec. The first one is about Java, as you could imagine. The second one is about the functional languages. And what was fun is that at the start of each study, we had trouble getting the academics or the other partners in the consortium to understand what our concerns were. So that's what we are trying to present today. Before beginning, the following examples do not aim at criticizing a particular languages, except for JavaScript, of course. And no languages were harmed during the work. So during the presentation, you might experience different stages. Okay, you know them. It's logical that some things seem to be strange. Some other you won't believe it. So sometimes you will try to think that we were mistaken, but we tried all the examples and they are real. So first, some illustrations. It's most of the presentation is about illustrations, and we're beginning with the elephant in the room, JavaScript.
I'll start by giving a few examples. So, besides the serious question, is a language better than another to write secure things? We started to collect stupid examples in any language. So, there were stupid things across the internet. Internet is full of stupid things. We like that, so we started collecting them, and we started studying them to try to understand why that happens. And believe me, we are still not done with that. So, for example, in JavaScript, you have comparisons between things. Everything can be written in JavaScript. Everything. It does not have especially a meaning, but it will get executed. The browsers or whatever always find a way to execute things. So if you write stupid things, like for example comparing a number and a character, it will say, for example, that it's equal. But if you do the same thing with another construction or often used, switch, it will say the comparison, the same comparison will just not be equal. So this is a start of the wondering. How could that happen? Because that really means that the language is not really understanding the principles of mathematics correctly. Well, we can do more things with that. For example, if you compare characters to numbers, well, let's say it's true. If you compare a number to some kind of float encoding, it will say true also. But if you compare two strings, it will say that it's not. In mathematics, that means it's not transitive, that equality is not transitive, and usually when you're angry with mathematics, things can get worse later. We'll see some examples of stuff like that later. We'll start by very obvious examples. Some of the next examples have been found in real-life code, and some of them have led to exploits and vulnerabilities. So if these ones are very obvious, don't get impatient right now. You're going to have more intelligent examples. For the same thing, you can say, for example, the plus operator. You could expect that it's not really commutative, but you would expect it to be associative. So depending on the order you pass arguments with the plus sign, you will get different results. In one of these three additions, JavaScript decides that it must happen the numbers before adding them. In the other two, it decides that it must add the integers before appending it to a string. So this already means that there are something strange happening. So we're starting, well, testing more stuff. So we asked some stupid question about, can we compare anything? Yes, we can. Does it give interesting results? Yes, for some definition of interesting. So the equal sign means that, for example, if you look at the numbers on the diagonal, you would expect it to be true, except a few of them. But you can see that some values are not equal to themselves. That is a bit surprising.
So the equality is neither transitive, neither reflexive.
Amongst that, for example, an empty array is not equal to itself. So when you start comparing things, that gives interesting results. But the comparison is not only that. For example, we tried lesser on equal. Well, it gives even more interesting. It could even draw some kind of logo or whatever. But you have some stuff, for example, the -1 encoded as a string that gives interesting comparisons right now. We did the same for strict lesser and for greater than. And believe me, if you display this kind fast, you will see that you have values that are greater or equal, that are lesser or equal, but are not equal. Also very interesting. So JavaScript is a new branch of mathematics. That's pretty cool. Yeah, that was us tearing some kind of blood tears. You would find that funny until people decided that crypto in JavaScript was a really pretty cool idea because everyone has a browser. Yeah, right. So you now have many implementation of very critical crypto operations, manipulating all your private keys that are done using this language. Please stop it. Do not implement crypto in JavaScript.
We're going back to more civilized languages. Okay, first shell. So this is a trivial example of a bug if you write a comparison in shell. You try to compare what the user has typed to the secret PIN code, and you used to think that only digits could be typed, so you use the dash NE operator. So what happens if you write the good code? It's okay. If you write a wrong number, it's okay. But if you write anything non-numeric or even the empty string, the access will be granted. So what happened here is that the exceptional case, the error case, was grouped with the else in the else with the authenticated case. So this is a stupid example, but bear with me. This, as a matter of fact, it's exactly one bug we had in GNU TLS last year. The other go-to-fail, you must have heard about the atoll go-to-fail, but there was another one, and it was exactly the same thing that I just described. It was a function that would return 0 if the certificate had been passed and was validated using the signature. It was 1 if the signature was invalid, but it was -1 if there was an error during the passing. So if you use if if and directly the result of the function, you have exactly the case I described earlier. What's more interesting is that the same bug existed 6 years ago, 6 years earlier in OpenSSL. So you could say that developers never learn, but it's also that maybe the language doesn't help you. If you want to have a Boolean that is 2 values, maybe you should use a real Boolean and not an integer. Okay, so you all have heard, I suppose, about Heartbleed, which was a way to get to the private keys. So here again, the C language was in part responsible because it doesn't help you to check the bounds of an array. So of course you know the consequences of the Heartbleed vulnerability, and the code was a simple buffer overflow in a reading instruction. And you also have the C code that didn't help you, and the use of traditional tools and compilers with the go-to-fail, this time the Apple go-to-fail. It's funny because all these bugs arose in 2014 in just a few months.
Message to people writing static analysis tools. This one is obvious dead code. At that time that was written, there was not so many tools warning about that kind of dead code. And it's still not in the compiler a solved problem. So our question is again and again, well, the tools could help you also to write less errors. I know errors are good for some people because it provides jobs and security experts and so on. But sometimes it could be good that the tools would help you find this kind of bugs.
And the last one, another real bug that, another real vulnerability that could have been a major bug, that was a proposed patch in the kernel, Linux kernel source code. And if you look at it quickly, you might not see the problem, but the problem is you have an equal sign and not equal, which again isn't very easy to spot if the compiler doesn't help you. Hopefully most compilers help you now. And here you just, by adding these 2 lines in the right function, in the right syscall, you could have a backdoor, an easy backdoor that would be triggered using a curious set of options. Okay, so another language that we usually use when dealing with development is Java. So when we look at equality is very, very complex stuff in computer science when you try to understand it from the theoretical perspective, but it's also difficult in many languages, apparently. So you have these integers that you try to compare. Okay, sometimes you do not have the equality that you think you had, but maybe if you compare 2 two integers that have the same value, you would like them to be equals in some way. As a matter of fact, the first one is true. So if I create two integers with the same value and this value is 42, the result is they are equal for the equal, that is the physical equality test. But it's not true anymore for 1000. So who wants to guess why? Okay, so the answer is... Okay, so Java reuses the integer object. That's strange, but they use a cache. There are some cache for the integer object that are less than, I think it's between minus 128 and 127, so just...
In Java, integers are equal up to 127. Besides that, they are not equal anymore. The reason is there is a cache. Okay, so maybe you can understand it, but our point is,
should the developer have to know that?
Do the developer has to understand that, and you get extra points if you understand that using reflection you can poison this cache, and using implicit conversions, for example, you can even poison any more things, like for example printing addition of integers, because they will get implicitly cast to the class integer, and then using the cache that would have been poisoned. So yes, Java use a cache, but do the developer need to understand that, really?
Again, in Java, another cool example, you might find more, I think I forgot to add the reference, but there is a cool book on Java, is Java Puzzlers. You have a lot of such enigmas, and you have to guess what the result is before turning the page. So, okay, obviously the result is the program will print bad things happen, because we have an open bracket, then two slashes that open a comment, but then you have 0A. So okay, we're back to the new line, and then you have 7D, which is the bracket, that's the closing bracket, and 7B, the opening brackets. So of course, this will print bad things happen. So you might not know that the UTF entities are processed before the compilation.
Yeah, and yeah. Okay. Yeah, you might notice that there is one language we did not say anything about right now. So this is my preferred. So this is also a picture of me. PHP will come back on this presentation. So let me start by a simple test. You have a string. So these are characters. You try to increment it by 1 and print it. And then you try again, but this time using the pre-incrementation operator 3 times. So what do we have? So the result for the first is 3. Wow, surprising. It's kind of, you choose one number in the string, you increment it, and you trash the remaining. Why not? Let's try following. So the following is even more interesting, because the first means that it's kind of incremented the string considering as an hex number, right? Why not? We try another time. Okay, so this is not a hex number because we would have 2DA. We have 2E0, which means it has done some kind of addition on decimal base.
With the carry.
Then used the carry on the hexadecimal number. That has no sense. And we have a string. Huh? I mean, we have a string, not a hex number as a result. And the third time is even more interesting because we get 3. So why 3? Any guess? Because
Yeah.
2e0 is a float, of course. So PHP
Yes,
has considered 2e0 as a float and then incremented by 1. So it's 3 as a float, because 3 without the point 0 is a float, of course. We tried to understand. We tried.
Okay, I'll take about more language, more different languages. First Perl, okay, you might have seen this. It was presented by researchers at the last CCC. Okay, we will consider a request, a SQL request used in a web application. And because the developer was conscious, he would use the quote method that will escape the quote character. So of course, if I use this and try to put a quote in my username, it will behave correctly and escape the quote. So good for the developer. It's perfect. Okay, now I try another thing and I add another username. So user equals and all the quotes I want, and user equals 3. Okay, this time the CGI param user is not only a string, it's an array containing 2 strings. So we have changed types. No, it's normal. No problem. But now, if we look at the code, since we have an array and we are trying to use this in a context in the second line, we can have the array be seen as not one array, but 2 values. So I had 1 argument, and now it's 2. So that's a real problem, because that would say that the quote will get 2 arguments instead of 1. Okay, so for now it seems not to be a problem, but I try to use 3, that is SQL numeric, as the second argument. So now I have a quote that is called with my string, and an argument that would say to the quote method, don't do anything, because it's a number. So
for the young guys not speaking Perl fluently, it means that the arrobas underscore is expanded as 3 different values instead of 2. So you are able to overwrite the type variable that would not be overridden in other case. So that means we did overwrite the type variable, and since there is a security test on the type just right after, then it gets into the problem that Olivier is describing.
So in this case, type confusion, that is the fact that we had 1 array of 2 values becoming 2 values, inside the language is very bad, and it leads to real security issues. A solution would be to test in every function you have, oh, okay, is it really 1 string, or is it an array of string? So again, is it the job of the developer to work hard to compensate the lack of guarantees from the language? Because I would like to simply say I have transmitted 1 argument and it's understood as 1 argument. Final point. So, okay, Python now. I like this one. Python is a great language with a lot of expressivity, and one construction you might know is the comprehension lists. In this case, I have a simple comprehension list where I use the construction to add 1 to every element of a list. So the question is, if I write this kind of stuff, how what is S after this construction? Okay, it's 3. It shouldn't. It really shouldn't, because if you had done the same thing using map, which semantically is exactly the same thing, you would not expect this S to be defined elsewhere, to be to go out of its scope. And as a matter of fact, it was fixed in Python 3. Yeah, it was.
So in Python 3, that doesn't work anymore.
Yeah, and but they could, because nobody uses it. But no, it's no.
That is a local variable.
If you show this to every computer science people, they will say, okay, in both cases, S is bound. It's a bound variable. And they fixed it. They fixed it, so they believe it. Okay, that's interesting, but I'm shocked it was there in the first place. That's why I don't write Python anymore. No, it's not true. Okay, still in Python, you can use almost anything in an if to check if it's defined or if it's zero or I don't know. So if you write some code to check that you have a start time and end time and the current time is between both of them, you might want to check that the arguments are defined. So you use if start time and end time, and then if they are both defined, you will compare the current time with them. So if I use this with today, if I could do this today, you can do this on your laptop with this function, and I use start time equals to 11 p.m. and end time equals to midnight. What should it return? It should return true, of course, because midnight is false. Midnight is false. So the if in line 3 returns false, and I go directly to the last line. So that was interesting because it started a long discussion on Python mailing lists. So okay, you have reference, and we will put the slides if you want to know more. Okay, well, this one is more fun than really. We didn't try to make it really a problem in a complex context, but it's interesting that if you have a tuple with containing an iterable and you try to update the iterable inside the tuple, you have an error that say no, you can't do that, but it's done. It's done nonetheless.
The variable was modified. So we're speaking to security guys, right? You know that it could be interesting to make tests before doing the action, right? That doesn't. Of course, this example is not a security problem, but it shows that there are really strange things happening in the Python engine.
Oh, okay. Sorry. Okay, and Ruby. In Ruby, you have two functions open that seem to do the same thing, or almost. That is open a file. There is just a little quirk that is the first one, the kernel open. Okay, I would have thought it was file open, but also allows you to use the pipe as the first character in the string. So if you have a file name beginning with a pipe, the idea is to execute the command, and the open result is the standard output of the shell command that resulted in the pipe in the command. So this means that if you have a file with a name beginning with the pipe, depending on which module you have open, be it kernel or file, you have a very different results. And this, as a matter of fact, it's resulted in I think in several CVs in I don't recall. I think it was in FTP servers or HTTP servers that would use the output to create a file. That is, when you wanted to save a file, it would use the file name you got from the internet, and using the open, it would lead to code execution.
Yeah. Also, please note that the function reading the pipe and interpreting it is kernel.open, not file.open. So it means that the function that aims to be the closer to the kernel as possible is the one doing the higher level stuff. Interesting, also. Yeah, right. Yeah, I can't say it's me that time. Well, we'll.
It's Halloween tomorrow, I think. No.
We'll be trying to get people mad at us in almost every language. So if you're still not mad at us at the end of this talk, we have a problem. But still, PHP, really interesting. This is a commonly used module, right? A very commonly used module to upload files. But it has a very interesting way of fixing the integer overflow, because in case of 32 bits host, an overflow can happen, and then size can be lesser than 0. And the way to fix it is to do some kind of black magic, adding 2 times PHP int max plus 1. If someone has an explanation, please raise the hand.
I think the fact that it's 2.0 is to make it be a float.
Yeah, I think it's trying to make it sound like a float, so the overflow does not happen, and then returning it. And I don't know how it will get interpreted later, because, okay, it was a float, but it can be interpreted as an integer. Oh, hell, whatever. This code, if you search substring of that in Google or whatever, you will find tons of real-life projects using that.
If you return the two operands, I think you will have another result. Yeah, if you switch to the operands, maybe you will have something different.
Yeah, sure.
That's the beauty of it.
So.
Okay, we have spoken about a lot of languages, but some of you might know that at ANSI we like one language in particular very much. It's OCaml. So we also have examples in OCaml.
Yeah, because we are French, we like OCaml. And because, well, we were trying to test it to see if it's really better than the other languages. And well, we found some stuff. For example, code is static. For example, you don't have any buffer overflow or stuff like that, which is nice for a language aiming for being strict and having some kind of security. But strings, by default, are mutable. So it means that in that example, for example, check C returns either OK or KO. We run a first call to this function. We put that into F, and then we write into F O and then K. Since the result should be KO, we used check false. We write into the string that was returned. So in a really functional language, no problem, because we have a copy of the string and we write on it, right? But in fact, no, strings in OCaml that aims to be some functional language are returned by reference. So if we write in a string, that modifies every later use of this string, which is not really nice for a functional language. So we wondered, could it be used for some kind of security problems? So this example will be on a function from the standard library of OCaml. So it's not our function, it's the standard library. We do the same. We convert false into a string, we modify it, and then we print it. And then the string is indeed modified. So even the standard library is affected. So, well, it's not only fun, because the problem is you can modify almost everything that is used as a string, as a constant string, like, for example, exceptions, pattern matching, and the car.escaped function, which is a security function that is used to escape characters and to be sure that you won't have any quotes or whatever. You just change the returns of this function, and then you can return the same as the characters that should have been escaped. So there is no escape anymore, and then you can use as a way to defeat the security, even in OCaml. So I think the word in English, the Care Bear, we kind of killed the bisounours, the Care Bear. Also, I would like to notice that there are some kind of strange things happening. For example, in OCaml, you have strong typing, which does not mean presses the keys stronger. It does mean that a type cannot be compared to another type without casting it explicitly. In that case, you create a module, crypto, where you add a value which is ID, val, no, ID,
That's ID.
ID, and then you hide another value inside which is key. The value of key is hidden. You cannot access it. And you have no way to do so. Except that the compare function in OCaml is polymorphic, which means writing another module which has almost the same signature and the same ID, for example. We can try the key, for example, from 0. We write a module that has the same ID and a value, and we compare it. We can't see what's inside the module crypto, but we can compare it to something. So by using simple comparison, we extract the value of the box using a simple algorithm. So this, sorry?
No, you can no because you have the comparison, so you can do a dichotomy. It's
comparison. Just a simple dichotomy, and it works great. Also, I would like to emphasize that for a language that aims to be strict, it has a really annoying problem. On 32-bit machine, it does not handle integer overflow, and there is no exception, no whatever. So for a strict language, that is a bit annoying. And also, in OCaml, integers that not go to 2 to the 32, but only to 2 to the 30 minus 1 and minus 2 to 31. That means 1 bit is used by the garbage collector. So integers in OCaml cannot go to 2 to 32, but only to 2 to 31. That is the hell of an annoyance when you're writing something that has to send commands to the system, because -1 is a lot of F and it cannot be encoded in native OCaml. And every integer is signed. Well, oh, right, okay. So it's really not me this time. So why do we care? Well, let's play a simple game. We do hashes of random strings, or not so random, and even a SHA-1. You shall not use SHA-1 anymore, remember. But anyway, neither MD5. So the equal function from PHP is kind of the same as JavaScript. It's great. It has nice features of doing whatever crap it wants to. So are some of these strings equal in respect to the equal comparison? Some of them, none of them, all of them? So the answer is D, all of them. As you can see, the hashes are not random. They have a specific writing form. There is a number of zeros, there is an E, and there are some numbers. No hex, no ABC, A to F value. Well, PHP has a really interesting way of comparing strings, because we have strings on left and on right sides of the equal operators, so it should be compared using the string type. Okay, for anyone writing a compiler, when you have string types, you compare using the type. But PHP, before comparing strings, decide to test if it can compare it as integers before comparing it as strings. So all of them are true, and that leads to a certain number of real-world collisions. These are not real crypto collisions, of course, but this has led to some problems in a lot of PHP forums in the password reset function, because the password that was generated was exactly of the form just up of the slide. So any other password also hashed, giving the same kind of number, was working. You have a lot of real password working. And of course, PHP BB was also affected, but it's kind of a feature of PHP BB to test every new exploit before the others. Right? So now, well, we are laughing about the languages. We are making friends because they like their languages, and they're telling us that we are just annoying them. But what can we do now? Meaning, is it really the problem only of the developer?
We have a longer version of this talk, and we had a paper published last year, and in which we wanted to tell people that the code and the writing is just a step. You also have to work before the specification step and after, that is until the runtime environment. So just, I think we only have one example in each. So about specification, I just wanted to show you an excerpt of the Java specification about clone. So I'll let you read this and let it sink in. So it's about clone.
Okay.
If you read that, you didn't get anything, because it says, okay, do whatever you want. Clone is a cool thing. The general intent is to do that, but do whatever you want. So what kind of specification is that? So what can you do about that? Nothing. It's also interesting to see that serialization also have the same kind of specification in Java. So the read object and write object methods, they have the same kind of language. So that is to say, it doesn't specify anything.
Yeah. If you are a developer implementing a compiler, you should not, but it can happen. Read that and try to implement the clone function. You cannot. There is, first, never written anywhere, you shall do that. Anywhere, it's not written. And there is written, it should be something approaching, it's even not a requirement. So you can do whatever you want, you can format your hard drive, it will be compliant to the spec.
And for the tools runtime, just an example of a C code that is funny, because if you look at this, if you write it, if you compile it, the first thing that will happen is that it will segfault. It's logical. It's only logical because you have a constant char string, and then you try to write inside. So, okay, it segfaults, but the compiler won't say anything in a lot of cases. And that's, I think it's inexcusable, because the compiler is producing code that it can statically know that will segfault. So the program is useless. This one is useless. But never mind, it continues working on it. So how do you what can you do to avoid that? You can use the -w write strings option that everyone knows, or you can use G++. Yeah, because it would seem that there was less C++ code that would generate false positive on this warning. So again, we would like the tools we use, the compilers, the analyzers we use to help us, to help the developers. Sadly, it's not always the case. Okay.
Yeah. So what now? Are we doomed to use tools that are broken? There is also a problem at the beginning, which is how do people choose a language when they have a project to write? Well, usually the answer is they choose what they know, which is not that bad as an answer, but there is not even a discussion about what language should be good or not. And usually, if they don't know anything, they choose a language for performance, because of course you have to be extra performant when parsing a config file. What you should do is not even that, is you should ask yourself questions, which is, I agree, pretty hard. What you want to do will not be the same for all languages. For example, if you do network performance stuff, yeah, maybe Python is not really the choice that is really interesting, because it will be hell as slow. But when you're doing parsing, for example, thinking of IDS, maybe using C to write complex parsers for PE files, whatever files, is not really the choice of the year, because parsing is really something sensitive. And using C to do that is really, really dangerous. But you cannot use a language for everything. We are aware of that. So we cannot tell you, okay, there is one language you should choose for everything. That doesn't work. So this is a compromise. You have to think about it and ask yourself, do you want performance, do you want security properties or not? But really, the performance cannot justify everything. Also, the language should help you. I would add as a note that please, language developers, stop adding equal signs. I mean, there is equal, 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 and then we're going to count in powers of equal right now. It's stupid. So the language should help you. That should be something interesting. Also, yeah, since you're providing us some work, because we have to deal with that kind of problems, we are well happy, but please always use the warning from the compilers. And GCC has some kind of interesting theory that all is not all of the flags, it's all of something. So when you use all, you have to add extra, and extra is not even all plus everything. You still miss some flags. So
I think in Clang you have W everything, which for now is really everything. But let us wait 2 or 3 years and it won't be the case. Just a remark, if you do happen to teach programming, please tell that to your students. Tell them to always use the warnings, because I do that, and now I won't accept any project that won't compile with these warnings on, because I think they should learn it from the start, and it's really a good thing in C, but in every language, I think.
Yeah. Also, on the behavior, never write something quick and dirty, or I'd also say Greek and dirty, because that doesn't work like that. You never write something and by saying, okay, I'm going to fix that later. That doesn't work. You never fix anything. And that gives vulnerabilities. So please, the first code has to be tested everywhere. Write test, that's better. Also, more time thinking, less time debugging, and debugging some nice side effect tools in multi-threaded code is a hell of a nightmare. So please, if you want to avoid that, also think about your code. Write it using simple code, it would be better. So good habits can help you. Test results, never assume that something is always true, because it's not. I mean, it's also using whitelets. You can test, for example, that a value, if you expect a login name, you won't test for forbidden characters. You have to test only if it's ASCII, for example, and that's all. It's a way of thinking that gives way less problems. Also, keep it simple. That's also related to the last sentence. Some people have a really cool I'd say feature of being able to write IOCCC code natively. When they write code, it's so obfuscated that you cannot understand it. IOCCC, if you don't know it, it's a really cool contest of writing the most obfuscated code that you could ever find. It's really cool. They just announced the winners from this year. It's really great. So when you have features of a language, no, it's not cool to think about using all of the features you can just to prove that you know the language well. No, it's not cool. It's just a nightmare, because the next student that will have to read your language will cry tears of blood. Also, Rust programs. We did not speak about Rust because we did not have time to study every new language. Thanks to language developers, we have every year tons of new language to study. So please stop also. But for Rust, using the macros, sometimes you end up having so many characters that it looks like ASCII art and not code anymore. It's not understandable. So you have to write code a way that it can be understood by someone else than you, not only you. Also, we tried to study something which is, would it be pretty cool to use different languages in the same program? For example, if I take the IDS, well, you could do the parsing using for example, functional language, and the network-related stuff in a really fast language as C or whatever. So it's possible, it's cool, it works. But it's way more complex than the average developer can handle. Sometimes it's even more dangerous because it gives communications, whatever. Sometimes the modules that you have to use, for example, in Python, if you use C types, it's horrible. It does horrible things. GR security will shoot it anymore every time you start a Python language, because C types is trying to make some crap with your data. So sometimes by using different languages, you have the problem of the communication between these languages. And now you have even more problems than when you started. So it's a pretty cool idea, but hard to use it, really. So I'd leave the conclusion to Olivier, but well.
Okay, we have been a little more chatty than I expected, but okay, sorry. Programming language, we think they have an impact on software security, and not only because you use this paradigm or the other one, but because there are a lot of things to take into account. There is no silver bullet in languages, but you have to know them. We would like to have tools that help us. And what we think is that to be a good developer, you have to know a little on your language. And that is why I told you about teaching. And finally, I think in this regard, for now, our job is safe because there is a lot of interesting languages to study again.
Yeah, and also you can help us because if you write code that is better, we would have less slides on the next presentation. This is only an extract of what we get on all languages. You can contribute. If you have examples of stupid things, please send them to us. We like new examples. But also, if you write bugs, please be creative because we always end up on the same bugs and it's really annoying for us. So please write creative bugs and send us your examples. So this is something you can help us.
Thank you.
Okay, so are there any questions for the French intelligence agency?
FIA.
What about Fortran?
We did not study Fortran. We did not study ADA a lot but we should have because we have someone who worked on it. But no, Fortran we did not.
The agency is recruiting. We are not enough to study all of the languages available. So